There are n factorial different ways of arranging n distinct objects into a sequence. What's the meaning of that? For example, if n is equals to 4, that means we have 4 objects, maybe A, B, C, D. Then we can arrange these 4 objects in any order, maybe A, C, D, B, B, A, D, C, D, C, A, B, etc. Then how many of such arrangements are there? The answer is 4 factorial, or that is 24. Okay, let's start from n equals to 1. When n is 1, there's only one object. Then, of course, we have only one way to arrange the object. If we have 2 objects, there are 2 different arrangements. Name the 2 objects by 1 and 2. We can arrange 1 first and then followed by 2, or 2 first and followed by 1. And we have 6 ways to arrange 3 objects. Take a look at the 6 arrangements. For the first 2, we arrange 1 first and followed by 2 and 3. And there are 2 ways to arrange 2 and 3. And if arrange 2 first, then we have to arrange 1 and 3 after 2. And there are 2 ways to arrange 1 and 3. Or if arrange 3 first, then we have 2 ways to arrange 1 and 2 following this 3. So we have totally 3 times 2 ways to arrange these 3 objects. There are 24 ways to arrange 4 objects. Okay, let's see how it related to the case when n equals to 3. Okay, we have totally 6 cases such that A is the first object. And when A is the first object, we have 3 objects followed by 1, and there are totally 3 factorial, that's 6 ways to arrange them. And then we have 6 ways to arrange 2 first, 6 ways to arrange 3 first, and 6 ways to arrange 4 first. Each will have 6 different cases because 6 is 3 factorial. So totally there are 4 times 3 factorial cases to arrange 4 objects. That is 24, or 4 factorial. When we have 5 objects, we have 5 choices to select which one to be the first object. And if we choose one object as the first one, maybe we choose 2 as the first objects, then we have 4 objects left. And there are totally 4 factorial, that is 24 different arrangements to arrange these remaining 4 objects. Because we have 5 different choices for the first object, so there are totally 5 times 4 factorial, that is 5 factorial arrangements to arrange 5 objects, that is 120. If we want to choose 2 letters from A, B, C, and D, there are 6 ways to do that. We may choose A and B, A and C, A and D. All the cases such that A is chosen has been considered. When we are talking about combinations, we don't consider the order how we choose the letters. So BA and AB are the same case, so we will have BC and BD. And all the cases with B chosen are considered. Now we start with C. CA is this case, CB is this case, so the only case left is CD. There are totally 6 cases. 6 is equals to 4C2. If we want to choose one letter from the 4 letters A, B, C, and D, obviously there are only 4 ways. Is that to choose A, to choose B, to choose C, or to choose D? And 4 ways. 4 is equal to 4C1. Now we are going to choose two letters from A, B, C, D, and E. First, we consider the case when A is chosen. And then we consider the case when B is chosen. Note that AB has been already considered. So we have three more cases. Now we have covered all the cases when A or B are chosen. And we can still choose C, D, or C, E, or the last case, D, E. There are totally 10 cases, and 10 is equals to 5C2. Now I want to choose three letters from A, B, C, D, and E. For example, I can choose A, C, and D, but choosing A, C, and D means that I drop B and E. If I choose B, D, and E, it is equivalent to drop A and C. So the number of ways to choose three letters is just the number of ways to drop two letters. But the number of ways to drop two letters is just the same as the number of ways to choose two letters. So the answer should be still 10. And 10 is equals to 5C2, but it is also equals to 5C3. Remember that we have NCR equal to NCN minus R. In general, the number of combinations of R objects choosing from n different objects is NCR.